Welcome to this new demo of Java under the hood, in which I will demonstrate method calls and the concept of the this pointer. The code I'll use consists of two classes: a rectangle class with four properties, x, y, height and width, plus a setHeight method. In that method, in order to set the height property of the rectangle, I need to use the this syntax, since both the parameter of the method and the name of the property bear the same name. So, using this in a setter. The other class contains the main method, in which two rectangle objects are created. For rect1, after that, the height is set to 10, and for rect2, it is set to 20. Two interesting things we'll encounter. First, what impact does the declaration of a method has on the internal structure of the object on a heap? Second, how is this implemented? Let's have a look in the memory layout. Let's start by setting up the stack frame of the main method with its arguments parameter. Then the creation of the first rectangle object at address 1000, and the creation of the second rectangle object at fictional address 1500. Looking at the internal structure of the object, which is exactly the same as explained in a previous demo where no set method was defined in the rectangle class, well, that answers our first question right away. Adding a method to a class doesn't change the physical representation of the object on the heap. But then one might ask, where is the setHeight located then? That'll be in a method area, as its name implies, no? Important to note is that this method is loaded only once in memory, and not once per object created or so, no. So how can this method know which object to use for setting the height property? That's where the this pointer comes in. Let's see that when we execute setHeight. When setHeight is invoked, a new stack frame is created for this method. This stack frame now becomes the current stack frame. Our method has one parameter, height. But unlike what you might expect, it will not be the first variable in the local variables array of the current stack frame, as we've seen so far. Instead, since in the main method setHeight is using object referred to by rect1, well, a copy of that value, 1000, will be stored in the local variables array at the first position, denoted by an implicit variable called this, or the this pointer. As a result, this points to the first object as well. And thus, we have access to the object from within another location in our code. Once this pointer is in place, the runtime takes care of the parameters. So next in the local variables array comes parameter height, stored in the array with the value of 10 at the second place in the local variables array. The stack frame is set up. Let's execute the statement this.height is height. Reading from right to left, we want the value of the height parameter 10 to be assigned to this dot, so we dereference this, the 1000. In other words, we go to object at address 1000. Then which property do we want to change? The height property. The end result is that 10 will be assigned to the height of the object. And that's all for this method. We leave it. The current stack frame is cleaned up, and we are back at the invoker, the main method. Then the similar statement rect2 dot setHeight with a value of 20. So setHeight is invoked, a new stack frame is created for this method, but it's exactly the same method as before. This stack frame now becomes the current stack frame. In the main method, the setHeight was invoked on object referred to by rect2. So a copy of that value will be stored in the local variables array at the first position, denoted by the this pointer. This now points to the second object. Next, the height parameter, stored in the array with a value of 20, received by the invoker. And the stack frame is set up. Executing the statement this.height is height. So again, reading from right to left, parameter height with a value of 20 will be assigned to this dot, so 1500 dot, we dereference the this pointer to arrive at this object. We want to change the height property, and this field receives the value of 20. That's all for this method. We leave it. The current stack frame is cleared, and we're back at the stack frame of the main method. The end result is that both objects have been changed. rect1 has now a height of 10, and rect2 has a height of 20. Okay, so far for this demo. See you, bye.